Okay, examples then, vectors and scalars. Here we got an example, Jim. Jim's walking around a shop, supermarket. You've got some instructions on how he walks there. So he goes in through the doors, travels 15 metres north, straight ahead. Then he turns right. 8 metres east, turns right. 4 metres south, turns left. 6 metres east. Two things have happened since Jim's walked in the shop. He's travelled a certain distance, but he's also had a displacement of a certain distance from the door. To find the distance he travelled is simple. That's the easy part. All you've got to do, add the distances together that he's travelled. When you work those out, 15, 8, 6 and 4, 33 metres. So Jim has travelled 33 metres. That's the scalar. Okay, doesn't matter his direction. That's his scalar quantity, 33 metres. We also have to find his displacement. That's the vector quantity. That's where you have to consider where he's been and then where he's going to end up. So I've started this one off already. I've sketched out, not a scale drawing, just a sketch diagram of how far he's gone. So we're interested in how far he's travelled from this point here to this point here. Now to do that, we can form a little triangle. Okay, so if we imagine it's a nice dotted line, linking the two, this dotted line is the bit we're interested in. This is the vector quantity that he's got. Okay, if we make this triangle up a little bit better, we add some distances to it, and you can see where I've got them from. So this is just simple Pythagoras. That's all we're going to use. A little bit of Pythagoras theorem. For those of you guys sat in maths thinking to yourself, where am I going to learn this? Where am I going to need this? This is where. So this length here, if we look at the top, I've got an 8 metre distance there and a 6 metre distance there. That's 14 metres. This distance here, if we look, we've got 15 metre length here, 4 metres there, so this can be taken away. So this is 11 metres. So to find our vector quantity here, a squared, b squared, c squared, a squared equals, a squared plus b squared, simple mistake, c can be made, equals c squared. C is the square root of a squared, which is 14 squared plus 11 squared. Okay, excuse me, sorry about that, I was just about to sneeze, didn't want to hear that on camera. Anyway, here we go then, using trusty Albert, 14 squared, 196, 11 squared we all know is 121. If you add those two values together and square root it, okay, that'll give you 315. I don't know where my square root button is. Oops, that's wrong. That's better. 17.75 meters. Okay. So, scalar quantity doesn't have direction associated with it, only has a value. So scalar quantity, distance, how far he's travelled. Vector quantity, how far is he from the door? Okay, so although he's taken a long roundabout way, he's only 17.7 metres away from the door. Oops, just realised you can't see my working out at the bottom. Alright, hope that helps.